Hey everybody, welcome to the May episode of the uh, DocumentDB Insider Hour of our Twitch show here. It's our... Oh, sorry, I had a thing going here. Welcome to the May episode of our DocumentDB Insider Hour. I'm your co-host Chad Tyndall. I'm joined by my co-host Karthik Vijay Raghavan. Welcome. And Karthik is going to be kicking off a multi-episode series on the well-architected lens for Amazon DocumentDB. And we're just going to kind of jump right into it. So I'm going to turn that over to him, and please feel free to ask any questions in the chat. We will address those live if we can. And let's just dive right in. Karthik, take it away.
Thank you, Chad. Can you hear me okay?
Yeah, sounds loud and clear.
All right, awesome. Hey, folks, thanks for joining. And like Chad said, today we'll be kicking this multi-part series of well-architected lens for Amazon DocumentDB. The table of content is like this, but we are just going to look at the first two topics for today. I'll provide an overview of what well-architected review is for AWS, and then why we need a well-architected lens for DocumentDB. And then today's content is going to be focused on the first pillar of our well-architected lens, which is performance efficiency. And then, like in subsequent episodes, we'll be talking about the other pillars. So make sure that you join us to hear more about those other pillars. So let's talk about well-architected review first. So AWS well-architected framework enables AWS customers to improve their cloud-based architectures and better understand the business impact of the design decisions that they are making by helping them to understand, learn basically on what are the strategies and the best practices for architecting in the cloud, and then measure their architecture against cloud best practices by using consistent process. That is very important, right? So that you measure your architecture now, 6 months later, and then 6 months from there. As long as you follow a consistent process, you'll be able to measure it in a pretty predictable way. And then finally, help them improve their architecture by addressing high-risk issues using these resources in the well-architected framework. So the well-architected framework revolves around these 5 pillars, right? The performance efficiency is one of the pillars, which focuses on using appropriate IT and computing resources and using them efficiently to achieve optimal performance. The reliability pillar focuses on ensuring that the workload, whatever workload you're deploying on cloud, it performs its intended function correctly and consistently when and as it is expected to. The third pillar is cost optimization, and it basically focuses on avoiding unnecessary costs so that you can use resources and ensure that your cost is on track and you're not wasting your money on unneeded or unwanted resources. Security pillar focuses on protecting informations and systems so that your data and the access to that is secured appropriately. And then operational excellence pillar focuses on running and monitoring systems to deliver business values and continuously improving the process and procedure. So this basically kicks in after you deploy your workload or the initial workload to production, and then how can you operate it efficiently. That's all operational excellence pillar focuses on. So these are all the general well-architected frameworks pillar. So while we have this well-architected framework and all the pillars, so what's the need for a well-architected lens, right? So a well-architected review looks at a workload from a very general technology perspective, right? Which means it doesn't focus on a specific workload and doesn't give you advice on specific workload. So that's why we created this well-architected lens for DocumentDB so that we can provide best practices, design principles, and questions to assess and review a DocumentDB workload, right? So this lens will help you perform focused reviews of your DocumentDB workload. And as you would see today, you would see design principles that are required to architect DocumentDB workloads, and when you follow that, you'll be able to make a better use of DocumentDB deployment. And then questions for each of these pillars of the well-architected framework to assess your workload. Again, very specifically assess your DocumentDB workload. So that's why we created this well-architected lens so that you can optimize your DocumentDB workload. Again, it's going to be based on those 5 pillars. So let's start with the first pillar, which is performance efficiency. Like I said before, this pillar focuses on using the IT and computing resources efficiently. And we'll be talking about the various key topics such as using appropriate resources and sizing, monitoring, and how you can make informed decisions when it comes to performance efficiency, such as you using the right indexing strategy, right document modeling strategy, and so on. Again, now we are going to be diving very specific into a DocumentDB workload. So that's why the topics are going to be focused on hey, how can I optimize my document model? How can I create efficient indexes and things like that? So each of these pillars, the way we have lined this up is we start with the design considerations, and then we will talk about, we'll double click into some of those design considerations and talk about general best practices and guidance for those of you that are using DocumentDB to deploy into production. And then we'll end each pillar with a set of questions that you should be asking yourself and evaluating if your workload adheres to the best practices and the design considerations that we've been discussing. So that's kind of the format for each of this pillar. So let's jump into it, right? So let's talk about the design consideration for performance efficiency pillar. So the first one over there is optimizing access patterns for compute and not storage, right? So for those of you that are familiar with the relational database world, we all have created data modeling, participated in various data modeling exercise, and we generally in relational create this third normal form. And this was created back in the 1970s to basically optimize for storage, because back in the days, storage was pretty expensive. The disk cost was expensive. So to avoid data duplication, third normal form was kind of prescribed as a standard. And that's what we've been following till date for relational, at least for the most part. Whereas when it comes to non-relational databases, NoSQL and DocumentDB is no exception, right? So you need to optimize your access patterns for compute instead of storage, so that you can leverage that performance benefits, because storage is no longer expensive. It's pretty economical now, and if you optimize your access pattern for compute, that will help with performance efficiency. And what I mean by optimize for compute is leverage the compute resources and use those compute resources appropriately, and instead of having to go and join across multiple data, multiple tables or collections, try to denormalize. That is one tip, and I'll talk more about document modeling considerations, which will help you determine how you can optimize your access pattern for compute. And like third normal form, there is no standard form or anything here that says this is how you would do it. It is basically whatever makes sense for your application access pattern. If your application is read heavy, denormalization generally helps. If your application has a good mix of read and write, then you'll have to weigh in various decisions, and I'll cover that in a bit here. So that's the first.
So just to ask a question. So this is really about structuring your data so the database has to do kind of the least amount of work to retrieve what you need, right?
That is correct. Yep, that's exactly what is optimization for compute, so that you can use your compute resources efficiently and then use more of them to do bulk processing or gather more data out of it. That's right. Cool. And then next is about how you access the data, right? Like where possible, use bulk operations over individual. Like let's say you're bringing in data from an upstream or a downstream system into DocumentDB, or ingesting data, maybe using like a NiFi process, a Kafka process, or whatever that is, and you're ingesting data into DocumentDB. These are all good examples and scenarios where you can use bulk operations like insert many, update many, and so on. And when you use these over individual operations, they are, out of the box optimized for performance. So, they leverage the available resources, efficiently, and you'll get better performance. Again, if your use case is going to be dealing with only individual documents, then it's totally fine to use those, but make those decisions appropriately. Instead of calling insert in a loop, just use insert many, for example. Right, and then connecting as a replica set. In one of our previous episodes, we talked at depth about how you can connect to DocumentDB and what are the various parameters and so on. So connect as a replica set, and use replica reads or replica instances because that will give you the scalability, and you can leverage multiple read instances to basically read data from DocumentDB. So again, you'll not be bottlenecked on a single instance and waiting for that instance to be freed up to serve your read request. Rather, you can just go scale out and go to multiple read replicas to leverage those to retrieve the data stored in DocumentDB. And then like workload specific connection parameters. Okay, before that, there's one point that I was missing. So okay, deploy application in the same availability zones as your database. So when you create a DocumentDB cluster, you can create something called as a subnet group where you basically tell DocumentDB, hey, create my instances in these availability zones. You can specify up to 3 availability zones. For optimal performance and avoiding these latency between AZs, which is again very, very minimal, but still we're talking about efficiency here, right? So deploy your applications to those same AZs so that you can minimize those network latencies between the AZs. And then use workload specific connection parameters. What I mean by that is connection pool, for example, use that based on what your query response time and SLAs are. We talked about this as well in one of the Twitch shows before, right? So if you're having like multiple queries, but anyhow one query is going to take let's say 10 seconds to respond, and if that's going to be the long pole on the 10, then you don't need to have like multiple connection objects for the remaining, let's say nine other queries that respond in a second, right? So understand what your SLA is and use appropriate number of connections, because every connection is gonna use system resources like memory and so on. So you want to be frugal about them, right? So use those connections in the connection pool. Determine what number is appropriate for a use case by understanding your query response time and SLAs. Likewise, the other connection parameters like connection timeouts, max idle time. These are all going to be very specific to workload. There is no standard number that you would be setting. Of course, there are default values, but in cases where it makes sense, adjust those default values, right? For example, max idle time. If you know that your session duration is not going to be more than 5 seconds, set the max idle time to 6 seconds or something, so that you give that connection back to the pool, right? So that no other connection is or no other request is going to be waiting on that connection, hence causing some latency when it comes to performance. And then when it comes to sizing, validate your instance size against your connection and cursor limits. So, I'll quickly show you where this link will take you to, right? So we have documented our limits over here, and as you can see in this, right? So the connection and cursor limit varies by the instance size. So as you scale the instances, you get more and more connection. So you should pick a right instance. If you know that you need like very high number of connections, or cursors, then pick appropriate sized instance. Right? And talking about sizing, the right way to do sizing is to use your data characteristics, such as what is your average document size, what is your index size, how many documents are you storing, what is the throughput that you want your workload to support. And then you can size your workload, and we have built the sizing calculator here that can just help you with the sizing exercise. So you can just go over here. If you're a MongoDB user, you can just run this particular JS script, which is gonna iterate through the databases and then through the collections and dump some information about the cluster, such as the document count, average object size, indexes, and so on. And then you can punch in that into a sizing questionnaire over here, which is a CSV file, and add additional information such as working set and whatever your throughput requirements are, and then upload that file and submit it. This tool will give you a good place to get started with sizing. Once you have that, validate that sizing that the tool provides by performing load tests, and then determine your scale needs. You may want to scale up or scale down or scale out. You can that's a good starting point with the sizing, and then run performance tests to determine where exactly you should be. And as you run your workload with that determined sizing, make sure to monitor performance. And then because this is always when you start, you're going to start at a specific throughput and data set size, and all workloads grow, right? That's what we've seen. So monitor your performance and determine when you should be scaling. And you can also implement auto scaling. DocumentDB does not out of the box support it, but it is fairly straightforward to implement. And to help with that, we have this blog that talks about how you can leverage DocumentDB metrics. And like, for example, CPU. The CPU utilization is a metric that we expose out of the box. You can look at that metric and say, hey, my CPU is at 70%. Let me scale my DocumentDB instances now. So this is a good blog to read through to understand how you can implement auto scaling. So that way you can be a little bit hands off with your cluster when it comes to scaling. So those are at a high level the design consideration. Now let's jump into some of the specific topics. We talked about optimizing for compute and not storage. So let's talk about document modeling consideration, right? So whenever you do data modeling, especially in a document database like DocumentDB or the likes, there's always going to be a dilemma, right? Whether you should refer a document, meaning you have one document and you have another document and you refer these by IDs, very similar to how you do in a relational world, or should you embed the objects into one document, right? So in most of the cases, the size of the document generally wins this argument. So let's talk about some of the components here, the considerations that you should be doing. And all you can see that when we go through this, these contradict each other, and it is intentional, right? So first of all, the sizing, or that's not the sizing, but the size of the document itself. When you're embedding document, and making the document as a single atomic unit, the size of the document quickly grows. It certainly helps when you embed, because you can quickly access the document in one read. But the size of the document grows, especially depending on the cardinality of your embedded documents, right? And DocumentDB has a per document size limit of 16 MB, which is pretty big. But as a best practice, we recommend to maintain the document size to be less than 8 KB, right? So when it exceeds 8 KB, there is going to be additional processing required. More IOs are going to be used. That's going to result in obviously performance cost, but also dollar cost, because one of the pricing dimension in DocumentDB is IO. And let's say you have a 12 KB document. Now that's going to, instead of one IO for read, it's going to use two IOs because the reads are at 8 KB. Likewise, instead of one IO for write, it's going to use three IOs because the IO count for writes are calculated by 4 KB writes. Right. So again, the summary there is try to keep the document size less than 8 KB. And also, when it comes to access patterns, it's strongly recommended to separate your mutable and immutable parts of the document, right? So what I mean by that is, if you have parts of the documents that changes quite often, and generally what we have seen is, most of the document part doesn't changes, and there is a small portion of the document, like maybe an 80-20 rule or a 70-30 rule, right? So you don't change the entire document very often. Some use cases does, but I'm talking about like more common. What we see is a small portion of the document changes. So keep that as a separate document, and keep the one that doesn't changes that often as a separate document. By this, when you're updating, you're only updating the 20 or 30%, which is now a standalone document, and saving on the IOPS that would have otherwise triggered because of the the other 70% that is not changing, because the operations are at a document level and not at a field level.
And does that advice only apply if your documents are bigger than 8 KB?
I mean, it is certainly advised if it is bigger than 8 KB. But even if it is smaller than 8 KB and you know that, hey, I'm just going to be changing. If it is like 1 KB, 2 KB, then no big deal. But if it is bigger than 4 KB, for example, and you know that the writes are going to be, we're going to be charging it at 4 KB, then, see if you can optimize that. It always helps to have smaller documents than bigger ones. Okay. And speed, right? When it comes to speed is basically how you access this, right? So the data model contains separate documents for each entity, or in other words, when you're referring these documents, the data retrieval will be slower because you'll have to do joins. In DocumentDB world or MongoDB world, we call it $lookup, right? So applications latency should be taken into consideration while you're doing data modeling, right? Embedding documents can result in better latency, but like we saw before, it can increase the size of the document. As we saw with the access patterns, when you embed it and you're just going to be changing a small portion of the document, embedding that into a larger document is going to result in overall increase in I/O and slow down your performance a bit. Right? And then the next one is about atomicity, right? So CRUD operations are atomic at the document level. Right, so you can basically, what I mean by that is the entire document can be committed or rolled back. Now, when you're storing different documents, or again when you're referring these documents, ask yourself, would the application be impacted if some documents are committed and some are not? Right, so one common approach, especially which we talked about optimizing for compute earlier, one common approach is to duplicate related entities in the same document for faster access and simplicity, and this will help you to avoid the need for ACID transactions when you embed them, right? So, for example, let's say you have an order information, and the order information has customer name and address, which doesn't change that often. You can duplicate the data, right? So that you don't have to maintain a separate person or customer collection and always refer there and do join, right? So, and when you're writing it, that the order information, the customer name is not going to change, for example. So you'll have to make those decisions, based on what parts of the document and what part of data changes often and not, if you are deciding to duplicate the data. And lastly, denormalization, right? So you can use selective denormalization to basically logically model your entity, right? Like I said before, it's totally fine to duplicate data. Just ensure that you don't increase the document size significantly by doing excessive denormalization. So, again, if the data model is going to contain separate documents, like if you refer, then it will be the application's responsibility for updating fields that are duplicated across all documents. And that's why I said, where the decision to document model should always consider your application access pattern and complexity. There is no third normal form or equivalent here. It all is going to be dependent on what makes more sense for your applications. Okay. So moving on to the next one, again, still around the access patterns and queries and stuff like that, right? How do you optimize your query, right? So I kind of split this into 3 buckets. Like when it comes to indexing strategy, that's basically is what is required to optimize your query for the most part. And the 3 buckets here are what should be the considerations during designing your indexes, during building your indexes, and how you should be using it, understanding how DocumentDB looks at your indexes, and so on, right? So let's talk about designing. The first and foremost, unless you're running an analytical query with no strict SLAs, you just need a response back. Unless it is that kind of a query, every single query that you're using should use an index, right? There's a default index of _ID, which is going to perform collection scan if you're going to be querying by any other attribute of the JSON document. So it's always a best practice to use an index. And also, another best practice is to limit this number of indexes to 5 or less for a collection. Now, the theoretical limit, I believe, is about 64, and it is documented in the limit document. But we recommend that you try to do about 5 or so on a per collection basis. And it might sound like, oh, only 5, it's too little. But when you go through this process, right, like identify appropriate fields for your indexing, right? So rank your queries, understand what are all the various queries, rank the queries by the frequency at which they are called. I mean, you can look at the queries per second and various metrics, and identify the common filtered fields, right? You can create DocumentDB supports compound indexes. And when you're creating compound indexes, you can certainly minimize the number of indexes. If you see that, hey, I have a need to use a large number of indexes because I have so many single indexes, you may be able to get away with the compound indexes. And when you're creating compound indexes, use the most selective field as the first field or the prefix of the index, and this will help to narrow the search and filter more documents upfront. And this is going to be the theme for optimizing queries, right? Like filter more documents upfront. That is what is going to be important. Think about this index scanning and how query can be optimized with an analogy for telephone directory. If you can filter who you're looking for, again, this is back in the days. Nowadays nobody uses telephone directory, but if you're looking for a specific person, if you filter to their first 3 characters, then you're looking at a limited set of data. That exact concept applies here too, right? Filter more documents upfront so that your query processor has to do less and less work, so that the query is more performant. And when it comes to creating indexes, this is very important, right? We strongly recommend that you create indexes on fields with high cardinality. What I mean by that is, don't use a field like a Boolean or a string that commonly occurs like a status value, right? In progress, completed, or anything like that, because it's going to be across multiple documents. And when you use a highly cardinal field like a telephone number or an email address, it helps with high selectivity of documents. Again, filter more documents up front, right? So for that, your index should be highly selective when it comes to selecting the documents, and ensure that the fields you index on narrow down the document search to keep this number as a guide. There's no reason to follow it 100%, but less than 100 documents, or 1% of what your total data size is in that collection, right? So this, if you follow this as a rule of thumb, then you'll be able to pick the right fields to index, which are going to be highly cardinal. And talking about compound indexes, they work well when the fields appear together in the queries. The fields are used individually. Generally, multiple indexes are a better choice, but if you have to reduce the number of indexes using compound indexes, that is another strategy we see customers use. So it is possible when you're using compound indexes, you can use equality or range query on the prefix, which is the first field. And if your query uses sorting, for example, you can use that field. Let's say you're sorting on age field, right, in the document. You can also use that age field as a suffix or as a later part in the order of fields that appear in the index. Use that as a suffix field of the index, and that's going to help you. If you go through the query stages, the plan stages, you would see that the sort stage is missing because you're storing the index in a sorted order. So if you're using sorting, then use that sort field in the suffix, which will help you to drop a stage from the query execution, which will again help with performance. And compound indexes generally has higher cost, and I'm talking about performance cost, not dollar cost, than simple indexes. So you would see that the optimizer tends more to pick simple indexes if they exist in your collection. So it's again very common when we develop applications, we create these simple indexes, then we optimize by creating compound indexes. And if you forget to clean up that simple index, it may be selected because of the performance cost. So if you're not using a simple index, just remove those unused simple indexes. And for whatever reason, if you have to use it, if you have to keep both simple and compound index in your collection, then you can use hint to select those compound indexes, because generally they'll be better performant, especially if the fields are appearing together. So those are all about the design stages when it comes to indexing strategy. When it comes to building an index, right? So in an ideal scenario, we would like to see the total index set in memory. But if the total index size comes close to or exceeds your collection size, that is an indication that you may have too many indexes, or you might have created index on fields that are less efficient, meaning your indexes are not very efficient or optimal. So again, look for those highly cardinal fields to create those indexes.
Are there any tools to allow people to discover if they have indexes that aren't being used?
That's a great question. Yes, we do have. It's not a tool, but it's a very simple query, and I can share a link after this presentation. It's basically the aggregate index query. So you can use the index stat and look at what indexes are being used and what are not being used, and you can find the ones that are not used and then delete them. Okay. Then, so when you're creating index on, let's say, large arrays or long strings that has very few unique values. Again, like I said, you have like some status fields which are like standard strings. It can result in inefficient indexes. And the reason for this is these indexes are all B-tree indexes, and when you're using let's say strings with less unique values, they're going to result in very deep B-tree, and hence, the index scan is going to take more time, right? So one solution for that is use string interning, meaning it will help you what is string interning is basically mapping unique strings to integers. Like if you've done an application development, if you're using like string to enum mapping, that's one example of string interning. Again, this is applicable to specific use cases, not all, but when you do string interning, you can reduce the index size and improve performance. At least it will be better than using those few unique value strings, because you're going to be like instead of you're using a long string, you're just going to be representing it with by an integer. So that's one of the technique or tip to overcome that. It's still ideal if you can find cardinal fields, but if you cannot, if you have to go by those status or whatever, maybe instead of status values as string, using string interning and using enum might help you. And then, when it comes to the use bucket here, right? Query Optimizer and DocumentDB, what it does is it uses the index stats for each collections, and it analyzes the query performance to select an appropriate query plan for you. So the optimizer may choose collection scan. You may a lot of times you would see this, right? So especially in a lower environment, hey, I have this index, but the optimizer is not picking it. It is still doing a index scan. Collection scan. Why is it doing it, right? It's because based on the collection stat, DocumentDB's query optimizer has determined that collection scan is cheaper than index scan. Now, if you run that at load, you would see your index to be picked, right? So again, the reasons for that is the query optimizer uses those collection stat at that point in time where you're running it, to determine appropriate indexes. And you can determine, right? You can see what plan the query optimizer is selecting by using an explain plan. And like I said, this information will be based on the stat at the time you run the explain query. And if you want to force an index selection, you can use hint, right? And if the correct index is not selected by default, again, use hint, right? So I talked about simple and compound index scenarios, right? The query optimizer most likely would lean towards picking the simple index, but because it's from a cost standpoint, it's cheaper. But if you know that the performance is better with the compound index, you can certainly use index to help with better performance there. Right, so those are all the indexing strategy and some of the tips and techniques for optimizing your indexes. Let's talk about application development, right? So what are the things you should be considering when developing an application, right? So again, this is going to be like specific to the queries that you're using, right? So you should understand that there are certain operators where applying some workarounds will help with increasing performance. For example, $LM match. DocumentDB currently does not support index for $LM match. So if your query is using a LM match, then consider adding a predicate or a filter on the field in the $LM match. For example, if you're saying, hey, in this array field, I want doing a $LM match on a key which has a value 1, then use a filter just before that LM match for that value 1, and now you can create an index on this field on the key for which the value is 1, right? So if you add this additional predicate and then index, that's a good workaround to help you with performance optimization for queries that are using $LM match. And also, the other operators like group and not equal to or not in, right? Let's take group, for example. DocumentDB will use the instance's freeable memory. And again, you can monitor this freeable memory by out-of-the-box metrics that is exposed. So DocumentDB will use this freeable memory to store the temporary results that the $group stage gives you. And if the query is using a $group and it is using it for a large number of keys, this is going to result, basically the query result is going to be large, right? Because you're querying $group on a large number of keys. And the instance, if it is like smaller in size, it could run out of memory. So the recommendation is when you're using $group, and if you know that there's going to be a large number of keys, try to break them down to lesser number of keys. Basically, it's like breaking a monolithic query into smaller subunits or subqueries. And then so that the freeable memory will be used optimally, and you're not going to be running out of memory, because it's a temporary result set that it stores and then discards and brings the next one in. Similarly, there are certain operators that when you're using, make sure you're using it in an optimized fashion. For example, if you're using regex, like a prefix match or a pattern match with regex, consider adding an explicit hint on the field name so that an index can be utilized, right? If you're not using a hint, regex queries are going to be doing a collection scan. So you can optimize performance of your regex query by using explicit hint. Likewise, when you have match or a sample, in your aggregate pipeline, right? Like if you're using match, try to use that as the first stage in your aggregation query, and then create an index. Why do you want to create an index on the field for match? Again, it helps with filtering the data upfront. All that you got to focus on is how can you make the query process life easy by filtering upfront. So use indexes appropriately and on appropriate fields, and use the order of the fields, right? Like the order of the operator here. Use the $match as the first stage, and just you create an index on the field that you're using for $match. And if you're using $unwind, remove the fields that are not required using a $project stage right before the unwind. When you use $project, it will limit the fields to the unwind operation to only those that are required, because you're explicitly saying project this, X, Y, and Z, so that only those are going to be used in the subsequent stages of the pipeline. Again, this will limit the resources that are required by DocumentDB to be executed in the subsequent stages of the aggregation pipeline. Again, filter up front, process less and less data downstream. If you're having to process more data downstream, then obviously the query processor has to do a heavy lifting, and the processing is going to be taking more time. So you can save performance by using a $project and say project specific fields in the subsequent stages. And that will help with performance. And then from your application, when you're connecting to DocumentDB, we've talked about using replica set with read preference secondary preferred, so that you can efficiently leverage read replicas and use bulk inserts, right? When you're, like I talked about, using those insert menus or update menus, and when you're performing bulk inserts, you can use batch and concurrency with appropriate values. This is very important, right? So you can determine what size you should be using for batch based on the document size. For example, MongoDB driver caps the payload at 16 MB. And if your document size, let's say, is 1 KB, just for ease of math here, right? Your match back size, considering 16 MB is the cap, can be about 16K or 16,000. And likewise, with respect to concurrency, you can go up to 16 concurrent queries per vCPU of your instance in DocumentDB, and then monitor the CPU and lower this number. So 16 is the max per vCPU. But if you see your CPU is pegged at a very high value, then you can lower the number. But the key thing there is when you are using bulk inserts, make sure that you're using appropriate batch and concurrency value as well, along that supports that bulk insert. All right, and when it comes to cluster sizing, there are a couple of dimensions, but let's talk about performance, because we are in the performance efficiency pillar here, right? So what determines your instance size is the processing power, which is the vCPUs, and the cache. So our best practice is to ensure that your indexes and working set are always going to be in memory. right? So also it is very important that you know that 2/3 of the available RAM. For example, let's take R5 2x large here, right? The memory is 64 gig, but what is available for your working set is 42.5 gigs, which is 2/3 of the number, because the remaining 1/3 is used by the control plane and the DocumentDB fully managed service processes, right? So when you are sizing, and the sizing calculator that I introduced earlier follows these best practices, but if you are doing sizing on your own, just make sure that your index and working set will fit in memory, and that is about 2/3 of the memory of the instance you're picking.
So I know that it's easy to calculate, how big your indexes are. We can just ask the database that question, but how do you calculate your working set size?
It's $1 million question, Chad, because it's always going to be tricky, right? So one trick that I explain to my customers is, do you know what your read throughput is, right? So if you know that you want to do, let's say your document size is 1 kilobyte, and if you know that you want to do 10,000 reads per day, right? So that is 10,000 times 1 kilobyte, whatever that number is, right? It's hard to do the math right now, but let's say it's 1 byte and 10,000 bytes, right? So if you know that 10 gigabytes is what you need on a per day basis, and you know that your documents doesn't change that often, and it changes probably on an average on a per day basis, then 10 gigabyte is your working set for data, right? And let's say you're storing 100 gigabytes of data, that basically is 10% calculation for working set. Now again,
but in the end, in practice, are we really just going to watch these metrics that you're about to talk about to see whether we have enough memory, or?
Yeah, we will, right? But this is like after the fact, right? So this comes after sizing, and certainly you should be monitoring these to resize as needed. But when you are sizing, you can determine what your working set is based on the read throughput. And then after sizing, let's say you did your performance testing, that read throughput, that working set calculation that you came up with is good, great. But let's say you're doing performance testing and you're not seeing the required performance, then there are some metrics to monitor. For example, buffer cache hit ratio and index buffer cache hit ratio. These basically are the percentage of requests that are served by the cache. And if you have calculated your working set right, you would be, DocumentDB would be having that data in memory or in the buffer cache, and then you'll see this buffer cache hit ratio to be high. We typically would like to see this at 95%, and we recommend that customers alarm if it goes below 90%. Right, so that is certainly a great metric to look for if you want to validate if your working set assumptions are good or not. Same thing is for index, right? So you can see how much of index scan is happening at the buffer cache level versus how much is scanning from the disk. And then talking about metrics, right? So these ratios, again, the ideal ratio is going to depend on what is your accepted or acceptable latency variation, right? So you can benchmark that during performance testing. And if you see that, hey, it was at around 90%, but I'm good. I'm happy with the IO utilization. I'm happy with the latency. Then that's fine, right? Again, it's going to be specific to the workload. But in general, if it is at 95%, you'll see the IO to be less utilized. So when we talk about cost optimization pillar, I'll cover those. But more and more you access from buffer cache, the performance is going to be better for obvious reasons. The other metrics when it comes to performance efficiency, again, there are multiple metrics. DocumentDB exposes more than 50, 55 metrics. I'm just talking about 4 from a performance efficiency, and I'll be introducing more metrics as we go through the subsequent pillars in the subsequent series of this show. Right, so the other 2 metrics are CPU utilization, right? And it's important that you monitor that and see if the CPU is pegged above, let's say 75%, whatever is acceptable for your organization. Some say 60, some go up to 80, but let's say it is 70 or 75%, right? And if you see that the CPU increase is organic, then consider scaling up. Or if you see that it is for your data has not grown. Why is the CPU utilization growing? Then see if there is any analytical query or something like that. Is anybody triggering some queries that you were not expecting? Or is there any new workload using your cluster, and so on and so forth? Freeable memory is another metric. And if you see this to continuously drop, there are a couple of things you can do. You can look at, hey, do I have those unused indexes? I believe Chad already shared the unused index query. So run that query and see if you have unused indexes. Is that capturing the the memory, and then remove them? Or if you think no, it's organic growth, then consider scaling up, right? So these metrics will help you determine when to scale, and the auto scaling block that I introduced earlier uses some of these metrics to determine when to scale. Right. So we talked about a lot of stuff with respect to indexing, document modeling, and stuff, right? So let's kind of close this with the query tuning. How do you, knowing all this, what can you do? How you can tune a query, right? So there are a couple of things here, right? When it comes to query tuning, understand the query plan, right? So you can use the explain, like I introduced before, and when you use explain with execution stats in its parentheses and as a parameter to it, it will tell you how much time is spent in each stage, right? So you can then determine, and the way you read the output of an explain plan is inside out. So in this example, the innermost thing over here, it says like collection scan, right? So and this collection scan returns 25 or 250,000 documents, and it took 466 millis. And then, on top of it, to do an aggregation, it took about maybe 20 milliseconds more. So it came to 485 and then 486. So you can see how much time is spent in what stages. And then you can determine whether you can optimize this. So in this case, probably this query can be optimized by adding an index because it is doing a collection scan. And you can enable slow query profiler, and you have to explicitly enable. By default, we don't enable this for you. You'll have to enable this in the cluster parameter group. And you can, when you're enabling it, you can say, hey, log all queries that are below a specific threshold. The minimum is 50 milliseconds. But if you want, hey, if the query takes 300 milliseconds, I'm okay. Anything above that, I need to know. You can then say the threshold is 300 milliseconds, and the profiler log will collect all those queries that are taking more than 300 milliseconds, and you can analyze the performance of those queries. And then you can use the db current op command to return all running queries, and it will also tell you if a query is blocked or waiting on something like a lock or anything. So you can determine, look at that, and see if a query is taking more than 20 minutes or whatever. You can just kill that. And then when it comes to query execution, right? So always try to visualize the flow, right? Start from the index. Like I said, filter up many documents upfront, right? How many documents did the index match for a given query? And see how much you can filter upfront. For example, remember those techniques with match. If you're using match, use it as a first stage and create an index on that. And then use project, right? Transform the information that you don't need. Because when you're writing project, using a project operator and writing that query, you're saying project these fields. You're also implicitly saying, do not project all the other fields, right? So transform that information and explicitly say what you don't need for the query, right? And if you're using accumulators like min, $max, $group, certain accumulators are expensive than the others. Like group and sort are expensive because they may use disk, right? For example, when you're using a $sort to sort your results, that may use disk. But accumulators like $min and max can just comfortably work in the memory, right? And it is important to understand that these accumulators will have to read all the documents scanned before you move to the next stage in the query. And this becomes important to understand, especially when you are using larger documents, because then there'll be spillover to disk. And when you reduce these documents, especially larger documents upfront, certainly helps so that you can get these operations done in the memory. Right. And how do you know if the $sort is or the $group accumulator is using disk or memory? You will see a metric called free local storage to drop when the disk is used by the queries, right? And see if you can use hint and specify an index that is optimal so that it can help you to do hash aggregates versus sort aggregates. The difference between hash and sort is hash is happening at memory, sort is at the disk. So again, these are all some of the techniques to monitor free local storage, and pay attention when you're using accumulators like group and sort, and look at the free local storage and make appropriate choices for indexes and use hints and things like that. Right. So that is for the query execution. And finally, to wrap up this performance efficiency pillar, we talked about a lot of things. We started with design considerations. We talked about document modeling, indexing strategy. We talked about application considerations and metrics. So what? How does this all come together, right? Ask yourself these questions, right? What are your query access patterns? Are you really optimized for compute? Are you having to do a lot of dollar lookups? Are you just like, joining left, right, and center, right? Are you using appropriate indexes? Are you using those indexes on highly cardinal fields? So understand what your query access patterns are and see if you're adhering to these best practices and design considerations. How does your application access data? Is there any data ingestion that is happening, right? So can the data be accessed in, if you're doing batch processing and stuff, can you use those bulk operators, right? Are your queries operational or analytical? Are you using just CRUD operations or aggregation? The reason it is important to know that is if you're using aggregation, then think about those various things we discussed about the pipeline. What should be the first stage in the query, how to create indexes and stuff like that. And then how many concurrent requests does the application support? This is important to know, are you going to be hitting those connection and cursor limits, right? So again, all these questions will kind of tie back to those design considerations so that you can help with performance for your workload. Same thing, how do you size your cluster? Ensure that you're following the best practices, like those 2/3 of memory is available, maintain that working set in memory, and very important, do performance testing and benchmarking. And once you do that, what next? How do you monitor performance of your cluster? Are you looking at the right metrics? Are you looking at CPU? Are you looking at the cache hit ratios? Are you looking at freeable memory? Are you what actions are you taking? Do you have an alarm set? Who are you notifying? And all that stuff is important to answer. And that, how do you monitor your cluster for performance? So that's about the performance efficiency pillar. I know it's like a lot of content here, a lot of technical topics. So if you guys have any questions, happy to take them now, or you can always reach out to us in our forums. So in the next episode, we will be talking about the next pillar, which is reliability. So Chad, with that, I'll give it back to you, and we have like 6 more minutes. Happy to take on any questions or discuss anything and everything around DocumentDB.
Yeah, I don't see anything in the chat. One question that I know that comes up a lot, is there any way to disable table scans from happening in the first place? So that you're forced to use an index, I guess.
Like when you say table scan, you're referring to collection scan, I presume.
Collection scan, yeah. Well, like in MongoDB, there's this no table scan parameter you can enable. Is there anything like that for DocumentDB yet?
I have not come across. That's a good question. I'll have to check. I have not seen that, so my initial reaction to that is no, but probably would help to confirm that.
Okay. I was Googling for it and couldn't find it, but I wasn't sure.
Yeah. Okay. Should be, if it is not supported or supported, it should be in the API, supported API and operator link documentation.
Okay. Yeah, this was great. It's so important, and in terms of applications, it's one of the most important pillars, of course, because if your application's not fast, no one's going to use your application. People, I know they've done studies, if it takes more than a second for your application to come back, they just close the tab and just move on to something else in their life. So this is so critically important. All right.
It is, yep. Very common questions we get around DocumentDB are, hey, how can I tune for performance? All this content is gathered from a lot of those customer scenarios and examples. So hopefully it was helpful.
And when you see customers migrating over from another NoSQL product to this one, do you see them having to make many changes? Are there differences here?
So it's the answer to that is depends. When you will have to make changes, especially if you're migrating from MongoDB, because DocumentDB is a MongoDB compatible database and you're migrating, it's important to understand that DocumentDB and MongoDB are 2 distinctly different services, right? There's nothing common in the backend. DocumentDB is built from the ground up as a purpose-built cloud-native database. So you may see the query optimizer picking a different index than what MongoDB is. And that's why it is important when you do the migration, it's important to do performance testing. And if you see that it is picking a different index, then we talked about a lot of optimization techniques, right? So look for options to see if single index is better or compound index is better or what. And the main change would be to tweak those indexes. So not necessarily an application level or code change, but the index that is being picked, you might probably want to tweak that to solve for the query optimizer. But that, again, that is on a case-to-case basis. In general, it should work as is. I mean, we have customers, like a lot of customers like Freshworks, Zulily, who are just able to migrate as is and get going with it. But if you have some edge case scenarios, you might want to take a look at the indexes and use the explain plan to see what index is being selected.
All right, very good. All right, everybody, that's our show for today. Of course, this will be available for replay up on the Twitch website. And our next show will be a month from now, June 17th at 8 a.m. Pacific, 11 a.m. Eastern Time. So we hope to see you then, and we'll be talking all about reliability with DocumentDB, right?
Yep, that's right.
All right. Thanks, Karthik. This was really nice, deep technical information. So hopefully people will get a lot of use out of it. Thank you.
Awesome.
See you all in a month.
All right. Stay safe, guys. Take care. Bye-bye.